Okay, so I'm gonna give you guys equation dy over dx. So for example, I gave you this equation. Now solve it. Use the separable method to solve this guy for me. You get it? You're always my best student, Qifang. You did it so quick. Okay, I'm gonna do it on boards. So we have like that, right? And we separate the variables, right? Separate the variables, put the y terms on the left-hand side, put the x terms on the right-hand side, right? So that's a strategy. Now, the second step, we're gonna do the integral. Okay, we're gonna do the integral. So now my question is how to do this integral. Any idea? Yeah, how to do the integral? 1 over y squared.
1 over y squared is the same as y squared dy. 1 over y squared dy. So you could.
What's the integral for this guy?
Y to the
a. Oh, very good. So y to the this guy, right?
Mm-hmm.
And then you can use power rule, right? Power rule. That's the key step. As long as you understand this part, and then you can do the integral. And be careful. When you do the indefinite integral, you always need to put constant c, okay? Don't miss this little, I call the little baby. Don't forget the baby. Okay, let's continue. Now we can simplify it. We're gonna have right, and that is the solution of ODE. Okay, the solution of ODE. Now I'm gonna give you guys another example. Let you guys try it again. So this example, and this one is a little bit tougher. I'll give you guys extra 2 more minutes. Okay. I told you it's a little bit tougher because you're gonna use the integral. You're gonna use the integral formula. Okay, now I'm gonna write down the answer on board. So let's take a look at this guy. The first step, we're gonna separate the variables. As you can see, we can separate the variable like that. Right? So move this y to the left-hand side, divided by y for both sides, times dx for both sides. We got this one, right? So we always put the y variables on the left-hand side and put x variable on the right-hand side, right? On the right-hand side. So we can see right, dy over y, like this. So now my question is, what is the antiderivative for 1 over y? What's the integral for this guy? What? You can't remember. Okay. Very honest.
Yeah, isn't that Ellen?
Good job, good job. So this guy should be ny. Okay, how about this guy? Is n 1 plus x. Okay, so I'm gonna remind you guys the formula for this. That's a typical formula. Okay, so if that's a coefficient for the x, then the antiderivative is going to be divided by a plus c. Okay. And if there's a coefficient is 1, then you're going to get what? Ln 1 plus x. Okay. So that is a composite function. Composite function. How you do the derivative of composite function. And most of you guys can get this one very, very quickly. And that is enough for me if you write down this solution like that in your test. Okay. But however, we can continue to simplify this guy. How to simplify it? Let me show you. So we can simplify. We do the exponential for both sides. Okay, and exponential for this guy, we have what? We have y. Is this guy gonna give you y? And this guy will get boils down to the okay, so basically we're gonna get what? We're gonna get y positive, negative, because we have absolute sign. We have absolute sign. When you remove the absolute sign, we're going to put a positive or negative. We have suppose I have two solutions, so we can write down a big 1 plus x. Let C1 equals positive, negative. Okay, C1 a new constant, and this new constant that equals this guy. Okay, so y equals is the solution of ODE. Okay, y equals C1 times 1 plus x is the solution of ODE. Okay, ODE. That's it. Now I'm gonna give you guys another example. Okay, another example. Stefan, did you get it or not? What's your answer? What? I don't think so.
The final answer.
Yeah, the final answer.
Have y equals per negative x squared plus b.
Plus C. I think you almost get it. Okay, let me do it on board. It's not too hard for these problems. So let's take a look. The first step, we separate the variables, right? Well, very straightforward, right? And then we do the derivative. And then, and the derivative of this guy gonna be this guy. Okay, with times 2, we got what? And this guy equals C1, right? So we got x squared plus y squared equals C1 is the solution of ODE. Okay. Otherwise, you can write down as y equals positive or negative square root. Okay. Both of them should be okay for me. Now, that's the solution of ODE. Now, I have another question. What is the solution of this guy? As you can tell, here I give you an initial condition. That is IVP problems, right? IVP problems. Like I mentioned before, first order differential equation requires one initial conditions, right? So since here we already solve it, we get this guy is a solution of ODE. Now I give you this solution, this initial condition. You need to plug in and get the C, right? C. So what are we gonna do? We follow the same strategy to get the solution of the ODE. Then we plug in the 4, x equals 4, y equals -3. Right? So we plug in. Right? We plug in x equals 4, y equals -3, c equals c1. And this guy equals c1 equals 25. Okay, now let's take a look. The solution of IVP is what? Is this guy. Okay, did you see the difference between these two? For the solution of ODE, there's a constant. For the IVP problem, the solution is always a unique specific number. Okay, be careful. Now I'm gonna give you guys another example. Let you guys try. For example. Now, if I give you and we have, oh sorry, we have y0 equals 1. Okay, try this one for me. You get it? Okay. I'm gonna write down the answer on board. Okay. Let's do it together. So the first step, we're gonna solve this ODE, right? Follow this the separate method, separate separable method. Sorry, separable method to separate the variables y and x to solve this ODE problem. Okay, so let's take a look. We separate the variables, right? And then we do the integral. And again, we're gonna have what? We have right? And then we're gonna get what? We're gonna get y squared, right? And then y squared equals right? And that is the solution of this ODE. It's very clear. It's the solution of ODE. Or you can write down y equals plus or negative square root, right? Square root. Now, after we got the solution, we have an initial condition, right? So when x equals 0, y equals 1. So x equals 0, y equals 1. You just plug in. Right? And we're going to get c equals what? This is 0, 1 equals negative 1/2. Okay. Here's a 0, 1 over negative 2c. Negative 2c go here, and you're going to get c equals negative 1/2. And when you plug in, you're going to get what? Negative 2 times going to be 4x plus 1. Okay, 4x plus 1. So now my question is, since here y squared can be written down as these two parts, right? We have two solutions. One is y equals positive, and another one is negative. Okay, my question is, which one is the solution? Or are they both of them are the solution of IVP or not? We got these two solutions. One is positive, another one is negative. Okay, so my question is, are these two or both of these two are the solutions of AVP or not?
Yeah.
Yes or no?
They're both.
Both of them. Are you sure? Okay, let's check. The things is for the initial conditions. This guy. So if we have the negative solution of this guy, you plug in x equals 0, 1 over 4 times 0 plus 1, and then negative. It's gonna give you negative 1, not 1. So remove or deleted. This solution should be deleted. Do you understand me? You need to check the initial condition. Although we can get two solutions, however, when you plug in the initial condition to check this initial condition. When you plug in the 0 here, you're gonna get -1, not 1. So that should be deleted. Okay, so this solution is okay. Be careful. Okay, it's a little bit tricky. That's the solution of the IVP. I'm pretty sure some problems on the my open math will be very, very similar to these problems. So you need to check whether it satisfies the initial condition. Okay. Now I'm gonna give you guys the last example. Oh, sorry. Should write down like that. And I wish this time everybody gonna make it. Okay. I wish this time everybody gonna make it. It should be example 3 now. Okay. Did you get it?
I had a fraction on my constant.
Oh, that's good. That's okay. That should be okay. I didn't check the answer yet. I just randomly designed this problem for you guys. Okay. I don't know the answer. It should be okay. Okay. It should be very straightforward. It's not too hard. Too hard, did you get it? Okay, good, good. Now, let me do it on board. So the first step, we're gonna solve the ODE. dy over y squared. Okay, and then we have what? Integral. We can put a constant on the side of the integral, right? So we have this guy, and the derivative should be this one. And I jump a lot of steps. If you don't just no, just stop me. Okay, stop me. Here is y to the power. Here's y to the power -2, and the derivative gonna follow the power rule. And here's y to the -1 should be 1 over y. -1 times positive 3x gonna be as positive, then negative. And then you're gonna get. So that's the solution of ODE. However, we want the solution of IVP problems. So we need to plug in the initial condition when x equals 1, y equals 3. Okay, so we just plug in x equals 1, y equals 3. So 3, 1 over, and then you're gonna solve it. This guy gonna 3 minus c times 3 equals 1. So 9 minus 3c equals 1 equals -8. C equals 8 over 3. Did you get the same number as I? Yeah. Okay, very good job. Very good job. Fantastic. So the solution for the IVP should be this guy. Okay. So the solution of IVP should be this guy. Okay, that's it.
One question. What is the symbol you use to signify what's IVP at the top? On the top of your equation? On the left, you just use a bracket?
Oh, yeah, it's a big bracket. Yeah. Okay, now we already finished the section 2.2, I guess. Separable method. Now we're gonna go to section 2.3. Today we're gonna learn something different. Okay, something different. So linear equation. As we know, for the first order ODE, we have a1x dy over dx plus a0x y equals gx. Okay, and we called this guy as first order ODE. And of course, people want to transform this first order ODE as standard form. What is standard form? Let's take a look. Dy over dx plus px y equals fx. And we called this guy as standard form first order ODE. Okay, because this guy is standard form. That is dy over dx, that's coefficient is 1. Previously it's a1x, right? Plus px y equals fx. And the thing is how to transform the equation 1 to equation 2. How to transform it? Just divide by a1x for both sides. Then you're gonna get the coefficient here is 1. Okay, that's the strategy. And now we also called homogeneous differential equation. Okay, that's third. If the right hand side fx equals 0, then we call it homogeneous differential equation. And of course, if this guy where fx doesn't equal 0, that means what? It's non-homogeneous. Differential equation. Okay, non-homogeneous differential equations. So that's the definitions. Okay, so let's take a look how to get the solution for the ODE2. Now we're gonna give you the idea or give you guys the solution. How to get the solution for the ODE2 for this guy. I'm gonna write down here. The solution of 2 is the sum of the 2 solutions. Is the sum of the 2 solutions. And these 2 solutions can be written down as y equals yc plus yp. And where, okay, how to define these 2 parts. So for the solution of 2 consists two parts of the solutions. One is yc and one is yp. Okay, what is yc? Let's take a look. Yc is a solution of homogeneous differential equation 3. And the yp is a particular solution of the non-homogeneous equation 4. Okay, so yc is the solution of homogeneous of the ODE3. Okay, and yp is the particular solution. Okay, particular solution. What it means a particular solution? Is we know for the ODE4, ODE4 has infinity solutions because always consists the constant C. Okay, you just pick a one solution, pick a C equals a specific number. That is a particular solution. Do you understand? As we know before, we have ODE for this ODE. Okay, for this ODE, we have infinity solution because C can be any numbers or real numbers, right? So for particular solution means what? You just pick a specific solution. For example, I pick a 1, 3, or 4, 5, whatever. That is a particular solution, okay? Okay. Now, since we know the solution of 2 consists 2 parts. The solution of this equation consists 2 parts. And solution of 3, the solution of 3, we can use the separable method. Separable method to solve it. And you're gonna get, I'm gonna give you the formula. So the solution of 3, you can use separable method. You're gonna get okay. And the particular solution can be written down as e to the power okay. Now, then we know the solution of 2 because the solution of 2 is a combination of this these two, right? YC plus YP. So the solution of 2 can be written down as y equals YC plus YP equals a little bit complicated for the particular solution. And this one is super important. I want you guys to memorize it, okay? So that's the solution for the ODE2, and that's the formula. That's the way we get the solution for ODE. Now I'm gonna use the this formula to solve a specific ODE. Let's take a look. The first example. Okay, and we can now follow the standard form. Follow the standard form, like I mentioned before. What is standard form? Wait a second, I need to find it. My slides. Oh yeah, I put it here. So standard form, you need to be careful. What is standard form? It's this guy, right? So we can see the px equals -3, and the fx is 6. Right? Follow the standard form, find out the px and the fx. That's the first step. Okay. First step. Find the px, fx. Okay. And now, second step, we calculate. We calculate the integral of this guy because we need this integral, right? We need this integral. So calculate this integral. For this guy, we're gonna get this one. Here, we don't put a constant c here. Okay, here we don't put a constant c. Usually, if we do the indefinite integral, we need to put a constant c. Right? Here we don't put it because in the formula already has the constant, and this constant already include everything. So when you do the integral for the px, we don't put the constant c there because we already have the c. Okay. Now, after you find this one, then you plug in to the formula. Okay. Plug in the formula. We have what? C e to the power -3x -3x, and fx is 6 dx. Understood? Plug in this integral here. Okay, and now you can simplify it. You can put the constant outside of the okay. Now the problem goes down to this integral. How to calculate this integral? We know the antiderivative of e to the power ax is equals what? Is eax divided by a plus c, right? That's what we learned before. The antiderivative of this e to the power ax is going to be like that. So the formula, this is a formula, right? So let's do this integral gonna be, right? Because here the a is -3, right? -3, so divided by -3. And then you can simplify it. Here's a -2. E to the power 3x times e to the power -3x, 3x minus 3x, e to the power 0, gonna be 1, right? So the solution for this guy should be this one. So y equals is the solution of ODE. Okay. Now I'm gonna give you guys an example. Later you guys try it. Try this one for me. Solve this guy. So follow the steps. We have 3 steps. The first step, you need to find the px and fx. The second step, do the integral of px, and then plug in the formula, right? Follow these three steps. Lacey, could you type your name in the chat? I want to check your attendance. Thank you. Okay, let me do it. So follow the steps. Px equals -2, fx equals 8. Right? And then second step, calculate the integral. Third step, plug in the formula. Right? Plug in the formula. So we have what? Negative 2x and e to the power -x and 8 dx. Right? And then we have what? Here's 8, put 8 outside. And again, we have what? Okay, e to the power 2x times e to the power negative 2x, going to be 2x minus 2x, e to the power 0 should be 1, right? So y equals this guy is the solution of IVP. Oh, sorry, ODE. That's it. Okay. I'm going to wrap it up class here. Thank you.